think there's some black from the tissue I should have not used. Unfortunately, this is not pure selenium dioxide, as there was something present to reduce to selenium. That's why it's not white. It's very interesting. Looks nice in the light. Might look pretty, but it's impure and the selenium needs oxidizing again. Nitric acid. This is returning it to selenium dioxide, I hope. Selenium, it's very orange, yellow in color. But nitric acid does weird things. There's a fair amount of pure stuff, and it's also growing on the impure stuff at the bottom, but something pure I can harvest anyway. There's been 2 beakers and 1 round bottom flask that were broken in the last day, so back onto eBay for me. Impurities seem to be at the bottom. There is some red there, which indicates reduction to selenium. It's kind of inevitable, I think, unless you have a stream of pure oxygen. I'm going to try and harvest what I can without mixing what's on the bottom with it. So like just the fluffy needles. Making a bit of a mess, but I believe this is close to pure now. Slight tinge on some of the bits, but you know, how can you avoid? Hello. Uh, 10 grams. I'm not going to bother with this, it's so impure and just sublimates as impure, or it reduces to selenium, one or the other. So this would be my waste. Pure selenium dioxide is here. This probably weighs about 11 grams. Okay, so 11 and a half. Selenium acid. Warm this up so that I can dissolve barium hydroxide. Barium hydroxide reacts with carbon dioxide in the air, so I need to limit that as much as possible, otherwise I'll end up with a cloudy solution of barium carbonate. And yeah, heating the water will increase the solubility of the barium hydroxide, and covering it with something should limit the carbon dioxide. Here's my barium hydroxide. I need to open this, weigh out 11.7 or 11 something grams, and add it to my hot water there. Limit the amount of carbon dioxide it's exposed to. 11.8. Add this to the hot water. Then we'll cover it. The solution is slightly cloudy as expected. I think all I need to do is add the two together, which will precipitate barium selenite, which I can filter and use for the next step. There we go, barium selenite. Oleum. It's just a very strong sulfuric acid, which I've added to some normal sulfuric acid just to have a strong sulfuric acid to add to my barium selenite. Barium selenite won't decompose until 400 degrees, so this should be an okay way to dry it out. Maybe turn it down a little bit. It's spitting. Whoops! I'm going to add some strong sulfuric acid to it. Which should give me selenic acid and barium sulfate. One can hope. But we don't want to use too much. Selenic acid is being produced in here, and the rest of it should be insoluble. So once I filter this, or once I finish adding the sulfuric acid, I can filter it and boil it down a bit, hopefully to concentrate some selenic acid. Interesting pink color. I will let this cool and filter it. Slowly dripping through it. Got a clear filter of water and selenic acid. now to evaporate some of the water. As it was evaporating, I noticed this color change, so I've taken it off the heat, and I need to do some more reading and perhaps try to confirm whether this really is selenic acid in water. Thank you again for watching. Please subscribe and click on the bell.